right.
Is that cream cheese?
Oh, so then if I did probability 8 on the video, then we don't have to go over those problems. Okay, we still don't have to go over every single one, people.
Let's go over the ones you have questions for first, and then go over the other topics.
This probability 7.
All right, we're gonna do probability 7. Okay, let's do the ones on the board first. We did, see how these problems that we did in combinatorics are coming up again? I told you they are. Okay, number 3. A committee of 4 is to be selected from a group of 5 men, 4 women, and 3 children. Find the probability that at least one from each group is selected. What do we do when we have this problem in combinatorics?
Specific cases.
You make the cases, so you got men, women, children. So what are the cases? You have to have at least one from each group. You could have 2 men, 1 woman, 1 child. 1 man, 2 women, 1 child, or 1 man, 1 woman, 2 childs.
Children.
Yeah, whatever. Okay, so what's the probability? Let's do the first one. What's the probability of getting 2 men, 1 woman, 1 child? 5 choose 2, 4 choose 1, 3 choose 1, right? Remember, we did this problem last chapter. It's not. Okay, what about the second case? 1 man, 5 choose 1, 2 women, 4 choose 2, and 1 child, 3 choose 1. And then the last case is 1 man, 5 choose 1, 1 woman, 4 choose 1, and 2 childs, 3 choose 2. That's what we did last chapter. We did the same problem. The only difference now is it's a probability. So now you just make a denominator. What's the denominator? If I have, how many total people? 12. And I want to make a committee of 4. What's the denominator going to be? 12 choose 4. Right? Because when you have a committee, the order doesn't matter, right? So it's a combination problem. You guys don't remember doing this? We did this multiple times during combinatorics. All those problems are going to come up again, except you're just going to have a denominator now. Okay, number 6. You guys don't remember doing this problem? A 3-digit number is going to be randomly built from the digits 0, 1, 2, 3, 4, 5, 6. What's the and using each digit at most once. What's the probability that the number is even? What did we do last chapter? You had to make the 2 cases, right? Because of the 0. So one case is 0 is the last digit, and the other case, when it's either the 2, the 4, or the 6, right? Is that bringing back memories? Okay, so if this is the 0, you got one choice. So if you use the 0, how many choices do you have for the first digit? 6 and then 5, because you cannot repeat, right? Now, if the last digit is either the 2, 4, or the 6, you got 3 choices. Let's say you pick the 6. How many choices do I have for the first digit now? Because you cannot pick the 0.
5.
You got 5. But now you can pick the 0. So it's 5. So what you have to remember is you got to make these 2 cases now. You cannot do it just one case, unless you do the probability that it's odd and then subtract it from the total, right? I mean, which is 1, of course. And then you divide by everything. How many 3-digit numbers can you make? Period. How many choices for the first digit? Anything except the 0.
6.
But now you can use the 0. 6 and then 5. And by the way, if you were computing this, let's say you're on the 10th. So you write this down, you're going to get 3 out of 4 points, right? How would you compute this? What would you guys do? Just multiply out everything like a mad dog? It's called factoring. What can I factor out in the top?
5.
A 5, and what's going to be left? 6 plus 15, right? And then you have 6 times 6 times 5. Look, the 5's cancel already. And this, of course, is 21, but 3 goes into that 7 times, and 3 goes into that 2, so you get 7 12s already. That's a lot easier than multiplying out all the numbers. It's called factoring and canceling. But it's up to you. You can do whatever you want, because you can have up to an hour, right?
Oh yeah.
Okay, number 9. I still can't believe there's only 4 questions. Peterson?
Well,
The probability that A will solve a puzzle is 2/5, and the probability that B will solve the puzzle is 3/7. If A and B both work on the puzzle, what's the probability that the puzzle will be solved? Now, What does that mean? The puzzle is going to be solved? No.
Oh, the guys are the branches.
That means at least one of them will solve the puzzle, right? So what are the cases for that? A could solve the puzzle and B will not, because then the puzzle will be solved, right? Or A doesn't solve the puzzle and B does, or they both solve the puzzle. In each of these cases, the puzzle is going to be solved, right? Or I can do the complement. What's the complement of at least one person solves the puzzle? Nobody solves the puzzle, and then subtract that from 1. So what's the probability that A does not solve the puzzle and B does not solve the puzzle? Where am I looking? What number is this? 9. Well, if the probability that A solves the puzzle is 2/5, what's the probability that he won't solve the puzzle? And what about B? It's 3/7, so 4/7. That's the probability that the puzzle will not be solved. Subtract it from 1. Finished.
Easiest problem.
Yeah, I know. That's why whenever you see or you have the phrase implied at least one, you do the complement and subtract from 1, right? We've been doing that for a month already. Number 11. I can't believe you guys aren't asking these other problems. You guys are picking the easy ones. Go to your room. 2 cards are randomly drawn from a standard deck. If both are spades, you win $238. Otherwise, okay. This is expected value. There's only 2 cases. How hard can that be? So all you have to really do is compute the probability that you get 2 spades. Spade on the first, spade on the second. What's the probability of that happening? Spade on the first.
4.
13 out of 52. And then another spade.
12 out of 51.
12 out of 51. There's 13 spades in the deck. And is that the only order you can get 2 spades in? Spade on the first, spade on the second?
Yes.
Yeah, so that's your answer. So 13 goes into 52. 4. 4 goes into 12. 3 goes into 51. 17. So the probability of getting 2 spades is 1/17. Therefore, what's the probability of not getting 2 spades? 16/17. So it says if you get 2 spades, you win $238. Otherwise, you lose $17. And do you guys know why I picked 238 and 17?
It goes into 7.
Yeah, because 17 goes into those numbers, and so the answer comes out nice. 17 goes into 238? Okay, I'll let you compute that. I'm not doing any computation. I'm not here to teach you arithmetic. Or am I? Number 7. No! Didn't we do this on the quiz? 2 4-sided dice. Write out the sample space.
You're just kidding.
1, 1, 1, 2. No, I love doing things multiple times. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 4, 1, 4, 2, 4, 3, 4, 4. The sample space is right there. Didn't we do this on the quiz?
Yeah, but this is 3 dice.
Where?
3 dice.
Where? Oh, it's 3 dice! Okay, well, I didn't read the problem correctly. Then we're not going to write out the sample space. Because that would be 4 times 4 times 4, which is 64. That's not that bad. Let's write it out for fun. No. Okay, so we know the denominator is going to be 64, right? 4 times 4 times 4. Okay, it says, what's the probability that the sum of the numbers facing down is equal to 7? Okay, so what numbers can you have that add up to 7? 0, 0, 7. You can't roll a 0. 1, 1, 5. You can't roll a 5 before it's the biggest number on there.
1, 2, 4.
1, 2, 4. However, how many different orders can you put these things in? So it's 6. Okay, what's another case?
1, 3, 2, 2, 2. 1, 3, 3.
Okay, we're looking for the sum equals 7.
2, 2, 3.
2, 2, 3. How many different orders, though, can you put them in? 3. Any other cases that add up to 7? 1, 3, 3. How many different orders? 3. Is that it? So the answer is 12 out of 64, and then you reduce. Sometimes you just have to write them out, man. And I think there's another problem in here where you gotta write them out, yeah? Like 4B or something? No, that's not it. Okay, so we went over all the questions you have now. What about the other problems? Just start from 1 and go.
Yeah.
You guys are shameless!
Okay, we don't need to do one. One is super easy. Yeah.
Really?
It's super easy.
Yeah.
It's ridiculous.
Yeah, you guys should at least try it first before you ask any questions. I keep telling you, if you didn't attempt it, don't even bother asking questions.
It's number 2.
Okay, number 2. The probability that Ernie will beat Bert at a particular game is 0.6, which is 3/5. If they play 4 games, find the probability that Ernie will win at least 1 game. Now, what does that mean? Ernie will win at least 1 game. He will win either 1, 2, 3, or 4. Or is it better to do the complement? Do the complement, which is he wins no games. So compute the probability that Ernie wins no games and subtract it from 1. So what's the only way Ernie can win no games? That means Bert wins them all, right?
Yeah.
So Bert. What's the probability that Bert wins the first game?
4.
Well, if the probability that Ernie will win is 3/5, then what's the probability of Bert winning? 2/5. So 2/5, 2/5, 2/5, 2/5. And is that the only order that Bert can win all 4 games?
Yes.
Yes, so there's your answer right there. Wasn't that problem filthy easy?
Well, no, you have to use the multiply now.
You gotta multiply that, come on.
16 over
25 times 25 is 625, everybody knows that.
Let's multiply.
Okay, are we doing number 4? Just do it, yeah, just do it.
Okay.
100 tickets are numbered from 1 to 100 and placed in a box. If 1 ticket is randomly drawn, what's the probability that the number of the ticket is divisible by 6 or 7? Now, when you see that word "or" there, what does that imply? You add. So what's the probability that the number is going to be divisible by 6? How many numbers from 1 to 100 are divisible by 6? Just divide 100 by 6. 16. So 16 over 100. What's the probability that the number will be divisible by 7? 7 goes into 100
14.
14 times, so 14 out of 100. Box that, that's the answer. No, because you counted some of them twice. So, which ones did I count twice? All the
42.
numbers that are divisible by both 6 and 7,
42,
right?
84.
Which means they're divisible by 42. So how many numbers from 1 to 100 are divisible by 42?
3.
What? 3? Who said 3? 2 out of 100, and there's your answer. There's your formula anyway. Anyway, if you looked at your notes, was this covered in the notes? Yes, here, does this look familiar from the notes? The probability of A or B occurring is equal to the probability of A plus the probability of B minus the probability of A and B occurring. Because sometimes you have overlap, that's why. You have to you cannot count things twice. Oh man,
4B.
4B. 2 tickets are randomly
Oh,
drawn.
man.
What's the probability that the product of the 2 numbers is odd? I'm pretty sure you can see something like this tomorrow. Now, if the product of the 2 numbers is odd, what does that mean?
The 2 numbers are odd.
They have to be both odd, right? So basically, we're just looking for the probability of drawing 2 odd numbers. Now, how you want to do it? 1 at a time? Odd on the first, odd on the second? Or you want to just pull them out both at once? I don't care which way, that's why.
Both at once.
Okay, both at once. So what's the denominator? There's 100 tickets, I'm going to randomly select 2. Now in there's 50 evens and 50 odds, right? Out of the 50 odd ones, how many ways can I select? 2? 50, choose 2. Finished!
Oh my god.
Yeah, you guys are really picking the hard ones. Number 5. 3 men and 4, oh, here's a good problem that might help you on tomorrow's test. 3 men and 4, duh, because it's on the practice test, right? 3 men and 4 women are randomly seated in a row of 7 seats. Find the probability that the men are seated in the first and the last positions. Come on, did we do this or did we not do it last chapter? We're arranging people in a row. Is this a combination or a permutation?
Computation.
It's a permutation because the order is important. So let's do the denominator first. Can we just put 7 factorial?
Yes.
Yeah.
How many ways can you arrange 7 people in a row? 7 factorial, right? Okay. Now, we got 3 men and 4 women. Men have to be seated in the first and last position. So 1, 2, 3, 4, 5, 6, 7. A man has to sit here and a man has to sit there. How many choices?
3.
Wait, let me look again. Yeah, you're right. 3.
4.
And then, no, it says 3 men.
2.
2. Now there's 5 people left. It doesn't matter if they're men or women. How many choices do I have for this seat?
5.
5, 4, 3, 2, 1. There's your answer. Let the canceling begin.
7.
Because you know 5, 4, 3, 2, 1 will cancel 5, 4, 3, 2, 1.
7.
Maybe you should write 7 forget 7 factorial. Just do this. 7, 6, 5, 4, 3, 2, 1. And then, 3 times 2 cancel 6. 1, 7. Are you mocking me? Okay, number 8. And let me know if I skip one. From a group of 5 women and 4 men, a committee of 3 is randomly selected. What's the denominator then? Committee is a combination, people. How many total people are there?
9.
So 9 choose 3. Okay. What is the probability that the committee contains at least 2 women? So what does that mean?
1 woman.
Either 2 or 3 women. Or do you want to do the complement? 0 or 1 woman subtracted from the total?
2 and 3.
Yeah, just no 2 or 3. So 2 women, 3 women. So out of the 5 women, how many ways can you select 2?
5 choose 2.
And then you need 1 man, so that's 4 choose 1. 3 women would be 5 choose 3, but then you need 0 men, right? You don't have to write the 4 choose 0. And there you go. That was very difficult. Okay, we did that. Okay, let's do number 10. We should have just gone in order. 3 cards are randomly drawn from a deck of cards. What's the probability of obtaining 1 pair? Come on! Okay, do a specific case. Okay, what's the denominator going to be? If I'm going to draw 3 cards from a deck of 52. Okay, you don't get any points for that. Now, we want 1 pair. Let's do a specific case, a pair of aces. So that means we need 2 aces and not an ace, right? Okay, how many aces are in the deck?
4.
How many ways can I pick 2 of them? And then the third card is anything except an ace. So how many cards in the deck are not aces? So 48 choose 1. Now that's the probability of getting 2 aces. What about like 2 kings, 2 queens, 2 jacks, so forth? And you times it by 13, and there's your formula. That will give you 3 out of 4 points. Part B, 3 of a kind. Well, let's do a specific case. How about 3 aces? So 52 choose 3 in the bottom. How many aces are in the deck? How many ways can I select 3 of them? Okay, so that's the probability of getting 3 aces. But what about like kings, queens, jacks, dot, 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 times by 13 again? It's exactly the same problems we did last chapter, except now there's a denominator.
Yay.
And the denominator is the easiest part of the problem. So what's the problem? We forgot about combinatories because of spring break. That was the problem.
Yes.
Okay, do you want to go back to number 1 or number 12? Come on, okay, 12 you can do, right? They'll draw the tree, right? You guys can draw the tree, right?
Let's do a student lecture too.
Let's do the lecture.
Let's see how many chocolates to turn on the whole board.
What?
Okay, let's go to probability 8 and let me do a few, since we got some time, let me do a few problems that's going to help you tomorrow. Like, do you remember the birthday
Is
problem?
there a test tomorrow?
It's on Thursday.
Birthday problem.
Here, I'll write it again. PCH test tomorrow
Go.
if you're odd periods, but the test is Thursday if it's even, which is you. Okay, let's look at number 6, the birthday problem. No. Let's do number 5. Because I know some of you, we had the same problem on the combinatorics test, and I remember a lot of people got it wrong. So let's do number 5. 3 children and 3 adults are randomly seated in a row of 6 seats. Find the probability that no child sits next to another child. Now, we're arranging people in a row, so this is going to be a permutation. What's the denominator going to be? How many ways can you arrange 6 people in a row? See how the denominator is always the... Go back to your seat and nobody will get hurt. Okay, we're going to randomly arrange 3 children and 3 adults in a row. Find the probability that no child sits. Do you guys remember this problem from the last test?
Yeah.
So we
I
subtracted
want
from
the
1, 2, 3, 4, 5, 6. Okay, let's do a specific case. The children have to be separated, that's why. Because if the children sit next to each other, all hell is going to break loose. So let's do a specific case. The children sit in seats 1, 3, and 5. So how many choices? 3, 2, 1, and then the adults? But it's not the only case where the children can be separated. How many cases are there? Well, they can sit in seats 1, 3, and 5. 1, 3, and 6. 1, 4, and 6. Do it systematically. See, I do all the ones with 1. Now do all the ones with 2. 2, 4, 6. Is that it?
Yeah.
Yes. And so times by 4. That 4 right there is probably worth 3 points tomorrow. Because that's the key to the whole problem.
3 easy.
How many cases? Anybody can do like a specific case.
Oh, I missed it last time. Yeah, this time I did it wrong.
Don't make the same mistake twice. Okay, the birthday problem, number 6. So I'm telling you, the birthday problem's on the test. You don't even have to guess. It's on there. You just gotta be able to do it. Planet Zix has 8 days in a year. 5 inhabitants of Zix are randomly selected. Find the probability that at least 2 of them are born on the same day of the year. So how did we do this again?
1 minus not born on the same.
Okay, so 1 minus that they all have different birthdays. Now we have 5 people, right? So just make 5 parentheses. Look, it's so easy. Just memorize already. That's not understanding. Okay, there's 8 days in a year. What's the probability that the first person is born on one of the days of the year? What's the probability that the second person's birthday is different from the first? And so 4. 6 8, 5 8,
Never.
4 8. Boom! That's 3 out of 4 points right there.
How would you kick it up a notch?
You'll find out. Yeah! Woo!
Wait, can we do a theorized example?
No.
Looking at it.
Okay, wait. I want to do problem
At
2.
least
Silence!
3 have the same.
2. Oh, there you go. B. 2B. Are you guys? You're not even reading 2B. I'm gonna send you out like the calculus students. And we're gonna from now on, if you're not even in the class discussion, we're gonna make it like calculus. You leave your iPad and phone in this class, and you're gonna sit out there and stare at the wall until class is finished. I'm not gonna just kick you out and then you can start playing games. You're gonna get kicked out with all your books in here, and all you're gonna do out there is stare at the wall. From now on, that's what's gonna happen. And there goes for the rest of you. I mean, it's bad enough you guys don't even do your homework.
What are you talking about?
Talking to me.
That's
I mean,
me.
No, wait. Oh, you want me to walk around now?
Wait, no. I was yesterday.
Here.
Yeah, me too.
Doesn't matter. You got the video.
I did most of them.
Okay, can we just do this? I lose my boy. Okay, you have tickets numbered from 1 to 32. I'm trying to help you on the test, people. Or I could just do nothing and let you suffer.
No, help us.
2 tickets are randomly drawn. Find the probability that the sum of the 2 numbers is less than 10. Now sometimes you just have to count them out. What's the denominator gonna be? You got 32 tickets, I'm gonna randomly pick 2.
32.
Okay. How many points do you get for that?
Half.
Nothing. You get nothing for that. Okay, now, it says the sum of the two numbers is less than 10. Sometimes you have to just count them out by hand. So, what?
1, 2.
1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1 and a 6, 1 and a 7, 1 and an 8.
Yeah.
2 and a 3, 2 and a 4, 2 and a 5, 2 and a 6, 2 and a 7.
2 and 8.
Less than 10.
3 and a
3 and a 4. How come not 3 and a 3?
Because you can't have two.
Okay, duh. 3 and a 5, 3 and a 6, 4 and a 5, and I'm done. So count. 1 plus 3 plus 5 plus 7.
1 plus 3 plus 16.
Is that right? Okay, there you go. There's your answer. And what the heck? We got time, let's do C. If 3 tickets are randomly drawn, find the probability that the product of the 3 numbers is even. Now, if you multiply 3 numbers together, what will give you an even number?
Even, odd.
What?
Even, 2 evens and an odd.
Wait.
How about 3 evens?
Yes.
What about 1 even and 2 odds?
Yeah.
So basically, at
even.
least one of them has to be even. So what do we do when we have the phrase at least
No
one?
evens!
You do the complement. So we're trying to find the probability that none of them are even, that means they're all odd, and then you subtract it from 1. So 1 minus, what's the probability that all 3 will be odd?
32.
16 choose 3 over 32 choose 3. Look how easy, you just gotta think a little bit.
We do 8. Please.
Okay, and good thing you asked that. Because I bet you a lot of you forgot about the prom problem, right?
Yeah.
Okay, 4 married couples are randomly arranged around a circular table. What's the denominator gonna be? 4 couples means 8 people.
7 and
No.
8.
8 bucks.
How many ways do you arrange 8 people around a circular
7
table?
factorial.
7 factorial, n minus 1 factorial. Good thing we're doing this problem.
Oh, yeah.
What's the probability that each person sits next to his or her spouse? So how did we do this?
You gotta group them.
The benches, remember the love benches? So if you have 4 couples, how many ways can they be arranged if they have to sit together? Well, you just make 4 benches.
Times.
Now, if you have 4 benches, how many ways can they be arranged around the circular table? 3 factorial, but on this bench get 2 people.
2
On this bench get 2 people. A double, a group.
Oh.
And there's the answer.
What is your problem that you?
So easy. It's just that you guys gotta remember. And then what about number 11, remember? The vowels are in alphabetical order. Does that sound familiar?
Yes.
No.
Yeah, but I don't know how to do it.
So basically, we should just study the last chapter.
Also.
That would be nice. How about you study these problems?
No, I haven't.
Nah.
I haven't done the other ones.
I'd rather study something else. I am going to randomly rearrange or pick or arrange these letters. How many letters are there? 9. Again, this is an arrangement, a permutation, so what's the denominator gonna be? How many ways can I arrange 9 letters in a row? How many points do I get for that? Nothing. Okay, but now, what's the probability that the vowels appear in alphabetical order? Now, that's not familiar. Here's a 9-letter word. 1, 2, 3, 4, 5, 6, 7, 8, 9. The vowels must appear in alphabetical order. So, let's say the vowels are in positions 1, 2, 3, 4, and 5. How many choices do I have for this vowel? 1, 1, 1, 1, 1, because they have to be in order, right? That's the A, E, I, O, U. Now, what about the 4 consonants?
4, 3, 2,
4, 3, 2, 1.
times.
However, is that the only case? Vowels in positions 1, 2, 3, 4, 5.
9 choose 5.
9 choose 5. Oh, you guys are remembering something. Out of those 9 positions, how many ways can I select 5 of them to be the vowels?
3, 13 to. Is this
No, that's the tree.
Isn't this?
Make the tree.
9 choose
Okay.
4?
Okay, you want me to make the tree?
No, it's okay.
Oh, look, that problem was on the math folder.
Are you the mathematician?
No, this is on the math folder. Okay, look, you want to do it for funsies?
Yeah.
Okay, we got 4 minutes left. Okay, let's just do it for funsies. A mathematician drives to work 5 days a week, taking the Leaky Leaky Highway 3 days and the Poly Highway 2 days. When she takes the Leaky Leaky, so you're telling me I'm a woman? You ask to find the mathematician, it says she.
Well, I read the problem.
Yeah, that's right. When she takes the leaky, she arrives on time 80% of the time. When she takes the poly, she arrives 60% of the time. On a particular day, the boss noticed that she arrived on time. What is the probability she took the leaky? So we're trying to find the probability that she took leaky, knowing
If she took that.
no, that she was on time. Again, if you cannot translate it to this, you're in big trouble. So this is the probability that she's on time and took the leaky, divided by the probability that she's on time, correct?
No, leak. Oh, yeah.
Yeah.
Yeah. That's it.
Okay, so what happens?
Oh.
She can either take the leaky or the poly. What's the probability of these things?
3/5.
3/5, 2/5. And then either she's on time or late, right? On time or late. On time or late. If she takes the leaky, she's on time 80% of the time, so 4/5 and 1/5. If she takes the poly, she's on time 60% of it, so 3/5, 2/5. So what's the probability that she's on time and she took the leaky? That's right there, sister. 3/5 times 4/5. What's the probability that she's on time? Well, there's two ways she can be on time. She can go leaky and then be on time, or she can take the poly and then be on time. So that would be 3/5 times 4/5 plus 2/5 times 3/5. Il est très difficile. It means it's very easy.
Oh. 12 plus 6.
Alrighty then. No, now can you see why I selected probability 8 last year instead of 7? There's more juicy problems in 8 than 7, that's why. Well, good thing we got this on video. Yeah, the bell's gonna ring in 1 minute.
I do so sure you did, bro. I was so sure you went. So he was like, so then he was like, hey,
Michel, vous travaillez? Oh non, nous regardons la télévision. Pourquoi? Le dupeur arrive dans une heure. S'il te plaît, maman, encore 5 minutes.
Si, senor.
Allez, ne discute pas tout le temps.